Welcome to this IT Explainer video, part of our integration topic range. In this video, we will cover the subject of API usage within SLM. API stands for Application Programming Interface. It's a set of rules and protocols that allows different software applications to communicate with each other. APIs define the methods and data formats that applications can use to request and exchange information. They act as intermediaries that enable the integration of different software systems, allowing them to work together and share data and functionality. The following information will be covered in this training. Chapter 1 will be accessing Atlas API. Chapter 2 will be API basic object methods. Chapter 3 will be API event endpoints. And Chapter 4 will be C# demo application. In Chapter 1, we'll be covering using Postman to call the ping endpoint, using curl to call the ping endpoint through the console, using a WinForm app in C# to call the ping endpoint, and SLM-API documentation. You can use various applications and languages to access the Atlas API server. Let's go over some of them. The first one is a simple C# application that receives the API URL, and once we click the button, it will call the ping endpoint and it will display the results in the console of this application. So you can see we received a response. If we take a look at the code, we can see that the click on the button is calling a get method with the API URL and the endpoint that we're calling at the moment, which is the ping. The result is output to the simple C# application. Another way to access the API is directly in the Windows console by using the curl command. Let's specify the verb of the endpoint. In this case, it's a get method. Then let's add the API URL. And the endpoint would be ping. Let's hit enter and we can see the response of the API. Another way to access the API is using Postman. Here we have the verb. This is a get endpoint. We have the endpoint URL, slm-go.manganslm.com/API/ping. If we execute, we'll get the same response. And also, we can access the API through the instance documentation in the API. If we type slm-go.manganslm.com/API, the documentation will load and we're going to be able to see all the endpoints that are in that documentation. For this scenario, let's just go ahead and test the ping endpoint. If we try this out and click execute, we're going to be able to see the response that we would get from this endpoint. In Chapter 2, we'll be covering the endpoints, including getting objects, getting parents, getting children, creating objects, updating objects, and deleting objects. To retrieve information about objects, users can utilize the object's endpoint. This endpoint requires users to specify the type of object it wishes to retrieve. For example, let's get information for sites. In this scenario, we need to type the site type ID as part of the endpoint URL. Before executing, we need to make sure that we add the API key in the header. So let's go ahead and execute. Upon execution, the endpoint will return the data for all 5 sites. Here we have a total count of 5, which is the number of sites that we have in the system. Users can also filter the results for specific data. If a particular site is needed and its object ID is known, then the object ID can be specified as a parameter. And the endpoint will return the filtered results accordingly. In order to get parents for a specific object, users can use the parents endpoint. Let's go over a scenario. Let's say that the user would like to get the parent for this specific unit. The information that the endpoint requires is the type ID, which in this scenario is unit, the hash value, and then add /parents. This is going to be the URL for the endpoint, object, type ID of the object, the hash, and then the parents. This endpoint requires authentication. The SLM-API key is passed in the headers. Upon execution, we can see the result is the enterprise and the site, which are the two parents for that unit. Results for this endpoint can also be filtered. Let's say we'd like to only retrieve parents of type enterprise. We add the type ID in the parameters, specify the value, and we're returning only the enterprise data. In order to get child data for specific objects, users can use the child endpoint. Let's go over this endpoint to see how it's used. The URL endpoint is composed of objects, the type of the object that we're going to use as a pivot. Let's say that we're going to get the children for this unit. Let's get the type ID for this object. It's going to be a unit. Then we need the hash for the unit. And then /children. This point requires authentication to be passed in the headers. Let's go ahead and execute. The endpoint will retrieve information for all the different data types of children for that specific object. Now let's say we would like to filter children for a specific type. Let's say that we would like to bring information for these two SIFs. Then in the parameters, we type ID, a value of SIF, and we can see that the endpoint has filtered the data according to the parameters provided. In order to create an object using the API, users can use the post object endpoint. This endpoint receives a payload with the type ID of the object that is going to be created, the parents for that object, and the data fields for that object. Let's go over a scenario. Let's say that we'd like to create a unit under the site London, UK. Let's grab the hash for that site. Then we're saying that we are creating a unit and that we're going to use these data fields for the unit: object ID, unit name, short ID, and unit type. These endpoints require authentication. The SLM-API key needs to be passed in the header. Let's go ahead and execute. As we can see, we've received a 201 response, which means that the object has been created. And we have the data for the object that was recently created, and the hash, which is a unique ID for that unit. Now let's go ahead and reload SLM. And we can see that under London UK site, we have the newly created unit with the data provided in the payload: the object ID, unit name, short ID, and unit type. In order to edit an object using the API, we use the put object endpoint. The information that we're going to require would be the hash for the object that we would like to update and the fields that we would like to update. Let's go over an example. Let's say that we'd like to edit the site address and the short name for this site. First, Let's get the hash for that site. It's going to be part of the API URL object and the hash for the object that we would like to edit. And then as part of the payload for this endpoint, we will send the fields that we would like to modify, in this scenario the short ID and the site address for that site. As we can observe, the verb is put. This endpoint also requires authentication, so the API key needs to be passed in the header. Let's go ahead and execute the endpoint. The return of this endpoint will contain the data of the objects with the data fields updated, short ID, and we have the site address. Now let's check the instance. Let's reload. As we can see, those values have been set. Now let's say that we would like to delete an object using the API. For that purpose, we use the delete object endpoint. This endpoint receives the hash of the object that we would like to delete. Let's say that we would like to delete this unit. Let's grab the hash value. Let's put it as part of the URL of the endpoint. Before we execute, we need to remember to pass the SLM-API key in the header for the authentication. Now let's go ahead and execute. We've received a 200 OK response. And take a look at the site. There's no units, and then if we refresh the interface so the tree is refreshed, we can see that the unit has been deleted. In chapter 3, we'll be covering how to create events in SLM via the API endpoints, creating bypasses, creating demand events, and creating test events. To initiate a bypass activation via the API, we will utilize the post endpoint events/bypass. The payload should include the function hash where the bypass will be established, along with the bypass fields. In this scenario, we're using object ID, bypass activation source, bypass activated date, bypass reset source, and return to service date. This endpoint requires authentication. Hence, we must pass the SLM-API key within the headers. We need to obtain the hash of a function where we intend to create the bypass. Also, let's provide the information for the bypass fields. Upon executing the call, we'll observe the response containing the hash of the newly created bypass, along with its associated data. Let's refresh SLM. We'll find that the bypass has been successfully created under the specified function. To create a demand event via the API, we will utilize the post endpoint events/demand. The payload should include the function hash where the demand event will be established, along with the demand event fields. The payload must also contain the device event fail data. Each device event needs to contain the device hash where the device event will be created. As with any other post endpoint, authentication is required. Let's execute the endpoint. First, we need to obtain the hash for the function where the demand event will be created. Then, in this scenario, let's create two device events with fail data for two different devices. Let's get the hash for an input device. And then let's grab the hash for an output device. Let's go ahead and execute the call. Upon executing the call, we will observe the response containing the hash of the newly created demand event with its associated data and the information for all of the device events related to the demand event. Let's reload SLM. We can see that there's a demand event that's been created. And let's check for the fail data that was provided in the payload. So we provided fail data for an input device. This is failed with dangerous failures. This is for the input. And for the output, failed with dangerous failures as well. It's worth noting that for the other online devices that didn't receive failure data in the payload, a past device event will be created. Another type of event that can be created via the API are test events. In order to record this type of event, the post endpoint events/test record is used. The payload should include the test group hash, where the test event will be executed, along with the test event fields, and the device event data that will be recorded along with the test event. For the device event data, we need to specify the device hash where the device event will be created. Let's go over a scenario. First, we need to get the test group hash. Then, let's create a device event under one of the devices that the test group tests. And let's use the sample data that we have for the test event. The same sample data that we have for the device event that we're going to create. Let's execute the endpoint. As we can see, the test event has been created. Here we have the hash for the test event, and the device and the information for the device event created as well. If we go to SLM and reload the interface, we're going to be able to see that the test event has been created. Along with the device event. One thing to note is that there's a difference between the test event and the demand event. When we run a test event, only device event data creates device events for the test event. As for the demand event, that information that is not passed for the specific online devices, a device event with passed values will be created. In Chapter 4, we'll be covering showcasing the utilization of the object's endpoint within a C# application. The purpose of this demo is to showcase the utilization of a couple of endpoints within the C# application. To run the demo, we'll need to enter the API URL. In this scenario, we're using the SLM Gold API as well as the API key. Upon clicking the Get Sites button, the application will retrieve data from our SLM instance using the object endpoints. It will be presented in the table below, displaying the site ID, site name, and description. Subsequently, as we click on one of the sites, the demo will use the children endpoints to retrieve the count of all of the functions found under that specific site. Now, let's take a look at the models used for this demo. The first one is a response model. As we know by this point, the GET API response will have the following format: status, data, total count, limit, and offset. The data will vary depending on the information that the user requests. Now, let's introduce the two additional models that we'll employ in this demonstration to fetch data via the GET endpoints. Firstly, the child data model will handle data retrieval using the children's endpoints. In this case, we'll only extract the hash and the label from our response, as additional information is not necessary at this stage. Secondly, we have the site data model, utilized to acquire site information. Similar to the child data model, we'll only extract the essential fields required for our demonstration: hash, object ID, site name, and object description. Now, let's take a look at the logic for this demonstration. The class demo contains a property called object endpoint, which is the endpoint that we'll be using throughout this demo. The method get is used to make a request to the API and retrieve data. The method takes in a specific endpoint to access. First, we establish the client using the provided API URL. Next, we construct the request and include the API for authentication. Then, we initiate the call. Upon receiving the response, we deserialize it, converting it into a specific type determined at runtime. Finally, we return the result. Another method within the demo class is the getSitesClick. This method is triggered when the button name getSites is clicked. It fetches information about different sites using the API and displays them in a tabular format on the program's interface. This method utilizes the get function to execute the API call, specifying the endpoint for objects as a parameter, aimed at retrieving information about the sites. The data grid view cell content click method is triggered when the cell in the table is clicked. It retrieves the unique identifier or hash for the selected site and then updates the pie chart to display information about the functions associated with that site. The populate function pie chart method updates the pie chart with the data about functions of the selected site. It calculates the number of functions of different types like SIF, interlock, alarm and BPCS associated with the site and represents the information in the form of a pie chart. As we can see, we are iterating through each one of these types so we can construct the children endpoint. The children endpoint will be objects site. We have the site hash, children, then the type ID, and then we specify which type we're searching for at this specific moment. We set the limit as 1 because we don't really care about the information of each one of the functions. We just want the total count, which will tell us the amount of functions for each specific type that we have under this site. Finally, let's see our demo in action. We have the API URL, which is the SLM Gold instance, and we've provided the API key. Once we click Get Sites, using the object function, the object endpoint will retrieve the list of sites in this instance. Then when we click on a specific site, we will retrieve the count of function types that exist under the selected site.